Hi, sixth graders. This is our first video of Unit 7. So add Unit 7 to the top of your notes page. And then this is on solving addition and subtraction equations. So label the top of your page with that. So let's think about what we know about the equation x plus 5 equals 8. If we look at this, we probably know right away, well, x is 3 because we know 3 plus 5 equals 8. But if I'm trying to figure that out and I want to get x alone, I could do x plus 5 and then subtract 5. If I'm going to add 5 and then subtract 5, I'm just going to be left with x. But if I'm going to do that on the one side, then I'm going to do it on the other side, which then if I'm subtracting 5 on the other side, then that's how I'm getting 3. So probably in your mind, you just knew that 3 plus 5 equals 8, but we can also think of it as, well, 8 minus 5 does equal 3. So whatever we do to one side of an equation, we must do to the other side to have the sides remain equal. So this is something you need to just pause and write in your notebook. We also need to make sure that we know what inverse operations are. So inverse operations are opposite operations. And then I just want to make sure that you know that addition and subtraction are inverses of each other. So you want to write something along those lines, that addition and subtraction are inverses, and then division and multiplication are inverses. So the opposite of addition is subtraction, the opposite of subtraction is addition, the opposite of multiplication is division, and then the opposite of division would be multiplication. This is also something that I want you to pause and write down. This video has a little bit more writing than the rest of the videos, but we're going to use these same steps for the rest of our whole unit. So our first step when we solve a one-step equation is to write the equation. Then we're going to draw our slide or our train tracks, which I'm going to talk to you in about a second here. Then we need to use the inverse operation to isolate the variable, which means that we want to get it alone. We'll talk about that. Then we solve for the variable, and then most importantly, we check our solution. So pause, write these steps down, and then come back. All right, we're going to solve some addition equations together. So here's our first one that we're going to do. Write this down. So the first step was to write the equation. Secondly is to draw our train tracks. So this is what separates one side from the other side. Each side is equal to each other. These train tracks keep it nice and organized. Then I look for the side with my variable and I do the inverse operation. I can see that x is being added to 6. And remember, we talked about inverse operations. The inverse operation of addition is subtraction. So that means we are going to subtract 6 to get x alone. But whatever I do to one side, I have to do to the other side. So I write it right underneath the 6 here. And I can see that if I have, let's get rid of that red line. If I have 6 minus 6, that's just 0. So then I'd have x plus 0, which is really just x. And then I do the other side. 4 minus 6. 4 plus negative 6 would give me negative 2. So that's my solution. But then I need to, and that's what we call isolating the variable. We got x alone. It's by itself. Now we need to go back and check. So we're going to take our answer, which we got as negative 2, and we are going to put it back into the original equation. But instead of x, we're going to use negative 2 plus 6 equals 4. I just rewrote the whole thing. And now I'm actually going to make sure that it works. Negative 2 plus 6 does equal 4. So that checks out, that works. And then I go back up and I circle my answer. My answer is x equals negative 2. This is just my checking part. Let's do another one. Y plus 9 equals 22. Write this down. We do our train tracks to separate both sides. I can see that y is being added to 9. The opposite of adding is subtracting, so I'm going to subtract 9. I'm going to keep it super organized. Oops, I was looking at the 22. And then I'm going to draw a line because that's the end of my first step. 9 minus 9 is 0. So I like to actually just cross it out, or I know some people kind of put a 0 around it, but I cross that out because that's gone, and now I just have y alone, which we wanted to isolate it. And then I do 22 minus 9, which is going to be 13. And then I go back and check. I always want to check because when the problems get harder, we do want to make sure that that is actually our answer. And this is the easiest and best way to see if you have a right answer. So we do 13 plus 9 because I'm literally putting 13 into my variable equals 22. Then I ask myself, does 13 plus 9 equal 22? Yes, it does. It checks. And then I circle. Because there's so much work that we want to make sure our answer stands out and is circled. One more that we're going to do together, and then you're going to do some on your own. So we have negative 5 equals g plus 6. So I do my train tracks. This is what you're going to do for the entire unit with multiplying, dividing, 2-step, 3-step, whatever. I find my side with the variable, which this time it is on the right side. And then I see that g is being added to 6, so I do the opposite, and I subtract 6. Notice that I was trying to find my highlighter thing. Notice that I'm putting it right underneath so that it lines up, because I can't really do g minus 6, but I can do 6 minus 6. And here I have it right underneath, so it just stays nice and organized. So 6 minus 6 is 0, that cancels, so I have g. And then negative 5 minus 6. So this negative needs to stay with it. We do the exact same thing if it was positive, except it's negative. Negative 5 minus 6. I think of my integer rules. Negative 5 minus 6 is the same as plus negative 6, which would be negative 11. I personally like the variable to be on the left side, so I'm going to flip it around. And then I'm going to go back and check. Negative 5 equals negative 11 plus 6. Does negative 11 plus 6 equal negative 5? Yes, it does. So then it checks and we're good. If you were to solve this and it didn't equal negative 5, like let's say we had negative 5 equals 10 or something like that, then you would know that negative 11 is not the correct solution, and then you would just go back and recheck your mistakes. Maybe you accidentally added 6 to both sides, and then you're like, oh, I was supposed to subtract, and then you're able to find your mistake. But these need to match up here in order to know that your solution is correct. All right, so I'm going to have you pause the video and do these 3 problems. Sorry, I'm trying to get them all on the screen here. So pause the video, do these 3 problems in your notebook, and then come back and check all of your work. Alrighty, here's my work for m plus 4 equals 15. Notice that I subtracted 4 from both sides. So then I got 15 minus 4 equals 11. Then I checked it by putting 11 back in for m. 11 plus 4 does equal 15. It works out, so then I circle it. I have 5 plus h equals negative 7, so I'm going to subtract 5 on both sides because that's the opposite of adding 5. I get h equals negative 12 because negative 7 minus 5 is negative 12. Then I put it in and I can see 5 plus negative 12 does equal negative 7, so then h equals negative 12. And then I have negative 3 equals f plus 4. So we're going to subtract 4 on both sides because f is being added to 4 right here. And then I have negative 3 minus 4 is negative 7. I flipped it around so f was on the left side. And then I have negative 3 equals negative 7 plus 4 to check. And it works out. So f equals negative 7. When we have subtraction equations, we do almost all of the same steps, except now we're going to do the opposite of subtraction, which is addition. So we have x minus 2 equals 1, obviously a super easy problem, which is good because then it helps us learn the steps a little bit better. So write this down. We have our train tracks. X minus 2 equals 1. The opposite of subtracting 2 is adding 2, so I'm going to do that on both sides. when I look at trying to get rid of this subtracting 2 actually goes with the 2, so it's -2 plus 2, which we know is 0. So that's why we're left with x, and then x equals 3. Then I'm going to go back to my equation, put 3 in. 3 minus 2 equals 1, which, yes, 1 equals 1. So then I circle that because that's correct. Let's do another one. Y minus 3 equals 4. And remember, if I'm going too fast, you can stop at any time and pause and write stuff down and come back and rewatch me do any of the problems. And also we'll do it in class together, some more examples, so that should help too. But please make sure you go at your own pace. So y minus 3 equals 4. Y is being subtracted by 3. So the opposite would be adding 3. -3 plus 3 is 0, so I'm left with y. 4 plus 3 is 7. And then I'm going to put 7 into the original equation. So 7 minus 3 is 4. 7 minus 3 is 4. So that checks. So I go back and I know that y is 7. Let's say I accidentally subtracted 3 on both sides. So if I have y minus 3 equals 4 and I accidentally did minus 3 on both sides, I would have gotten, first of all, -3 minus 3 wouldn't cancel out, but if I thought it canceled out and I had y equals 1, and then if I put that back into the equation right here, 1 minus 3 does not equal 4, so then I know, oops, I made a mistake and that doesn't work. And then -8 equals g minus 6. So I got my train tracks. I look on the right side because the variable is on the right side. G is being subtracted by 6. I do the opposite, which is adding 6. -6 plus 6 is 0, so it leaves me with G. -8 plus 6 is -2. I'm going to flip that around. And now I'm going to enter in what I think is the answer, which is -2. Into the original equation, and I do know that -2 minus 6 does equal -8, so that checks, and therefore then I can circle it. Okay, 3 more questions that I want you to do on your own. These are very important to know and understand because this is the foundation of our whole unit of building equations, or of solving equations. You need to make sure you understand all of the steps so that, again, when it gets harder, you know the steps. So if you can do it in your head, great. You should be able to do some of them in your head, but you need to understand all of the steps, and that's what I'm going to be looking for in your notes. So pause me and do these 3 problems. Alrighty, so looking at these problems really quick, m minus 7 equals -12. Because m was being subtracted by 7, I'm adding 7 on both sides. So then I get -12 plus 7, I got -5. Then I put it back into my equation and checked it, and I got -12 equals -12. So then my solution is m equals -5. Remember, the solution is what the variable equals, not what the checking part is. -5 equals h minus 6. I'm going to add 6 to both sides. So then I get h equals 1. I flipped it around right here, and then I put 1 back into the equation, which was h minus 6. So 1 minus 6 does equal -5. So my answer then is h equals 1. And then -18 equals f minus 4. So I'm going to add 4 to both sides, and I get f equals -14. There's my checking. So that means I know I am good to go. These are just our subtraction and addition property of equalities. So I just want you to know and remember that if you subtract the same number from each side of an equation, or if you add the same number to each side of an equation, the 2 sides will remain equal. So basically, whatever you do to one side, you have to do to the other, and if you do the exact same things, then the equations will remain the same. Make sure that you have your notes in a safe place so that they are in class tomorrow for me to check, and have a great day.